What are design patterns and what problem they solve? Design patterns are reusable solutions for common problems in software design. Suppose you want to implement logging for your application, okay? Now almost every application will have logging in it. So you will try to find the best logging design technique that you will implement it, right? Now this technique, if it is really good, then it will be used by many developers and then it can be a reusable solution. Now you will get many reusable solutions in Stack Overflow, GitHub, but are they all design patterns? The answer is no. The reusable solutions which solves the problems related to designings of the software, only those are design patterns. For example, while creating an application from scratch, when you are designing the classes, then how the classes will communicate with each other. For that, if there you will use some reusable solution, then that will be a design pattern. What are the types of design patterns? First, we have three categories of the design patterns: creational, structural, and behavioral. Now, under these categories, we have the type of these design patterns, and under the creational category, we have factory, method, builder, abstract factory, and singleton design pattern. Under structural category, we have adapter, decorator, facade, and proxy design pattern. And under the behavioral category, we have observer, strategy, command, state, chain of result, responsibility, and visitor design pattern. There are many more other design patterns also, but these are the most popular ones. Now, before learning these types of design patterns, we must understand the categories of the design pattern: the creational, structural, and behavioral. What are creational design patterns? Creational design patterns are design patterns that deals with object creation mechanism. Now, object creation of a class is so simple like this. Yes, what is the problem here? The reason is the problem is in large or enterprise big applications. If you want to change this class from cat to dog, then you have to change it everywhere wherever you have used it, right? And then it will be a testing issue. You have to retest all the classes like pet class this, okay? So that's why writing code like this can be problem in future when you will try to whenever you will try to enhance your application, okay? Therefore, we have design patterns like factory, method, builder, abstract factory, and singleton, which can optimize the object creation technique for the applications, okay? What are structural design patterns? Structural design pattern is used to manage the structure of classes and interfaces, to manage the relationship between the classes, okay? What is the meaning of relationship here? Let's try with the help of adapter pattern, which is a structural design pattern only. Suppose you have an application or software which is producing three outputs, okay, and there is one other application which is taking only two inputs. Now how you will connect these two applications? How you will connect the relationship? It is three output which is taking two inputs. Now here the answer is you will create an application in between them which will take three outputs, and it will give two, and it will produce two outputs, sorry, which will take three inputs of first application, and then it will produce two outputs for second application. Now you see these applications are well connected with each other. So that is adapter pattern, and that is like you are creating the structure so that a relationship between the classes. Now here is I took the example of application, but the same can we can do with the classes also. Similarly, like adapter, we have decorator, facade, proxy design pattern, which are also like the structural design patterns also. I hope now you understand what is the structural design pattern. What are behavioral design patterns? This is the third category of the design patterns. The definition is behavioral design patterns are the way to communicate between the classes and the objects. So you have to choose the best way to communicate between classes and objects, okay? For example, let's take example of a strategy pattern, which is also a kind of behavioral design pattern. In strategy pattern, we can choose the best strategy at runtime for doing any operation. Here below you can see this flow. We can select here the best strategy out of quick sort, insertion sort or merge sort to sort the list at the runtime. And here are the behavioral design patterns: observer, strategy, command, state, chain of responsibility, and visitor design patterns. So basically, in short, how to communicate between the classes, that for that you can choose one design pattern which will give you the options at the runtime. So that is called behavioral design patterns. What is singleton design pattern? This is a very important question. The definition is: the singleton design pattern is a creational design pattern that ensures a class has only one instance of it. Only one instance. Meaning, until the application is running, only one object or instance of the class will be used. Multiple objects will not be created of the same class. And then the same object will be shared by the multiple requests also. Okay, so normally we have class like this with method inside it, right? Then we create the object of the class like this and then call the method from the object, right? It's the traditional way. In our applications, wherever we need this method, we will call at multiple places in multiple requests. We create the object of the class multiple places then. But in singleton pattern, we have to create the object only once and then we have to use it at multiple places. This is how we are going to create the object of the singleton class via this getInstance method. Okay, now this code is implementing singleton class and it has 4 steps which I am going to explain. First step is declare class as sealed to prevent any further inheritance. Now, if some other class will inherit this singleton class, then it will violate that singleton design pattern. So that's why we are putting sealed here, so that any other class should not inherit it. Second step is declare a static instance of this class, because only static instance you can use inside static method getInstance. Okay, so like if you will not put it static here, then inside getInstance method you getting this if instance equal to null, that instance will show you the compile time error. You can try it, it will not allow otherwise. Third step is to create a private constructor so that no one can create the object of this singleton class. So no object we need of this singleton class, that's why private constructor. Now sealed will not let anyone to inherit from this class, and private constructor will not allow the object creation of this class. Okay, that is good for singleton. And the last step is to create a method, the getInstance method, which will check whether the instance is null. If yes, it is null, then it will create the new instance, and if not null, then it will return the same instance which is already created by which is already created at first time. This is the way we will use same instance again and again for multiple requests, and this is the purpose of the singleton design pattern. How to make this singleton pattern thread safe? Now let's see what is thread safe and how we can make the pattern thread safe. This is the normal singleton pattern we already discussed in previous question. Okay, now suppose we have a multi-threaded application in which we are working, and now here 2 different threads reach here at the same time at this position if instance equal to null. Then both these threads T1 and T2 will check this condition here, and for both threads it will be null, right? Then both will enter inside this create new instance, which means now they will create two instances, which is the violation of the singleton pattern. So now we have to make our singleton pattern thread safe, so that it is not allowed. Okay, this is not good that these 2 threads are creating 2 instances at the same point of time. Now for that, first we will create a read-only object padlock like this, and then we will apply this lock method over this if condition. This lock will allow only one thread T1 at a time inside it. So okay, so this lock, what will it will not allow both the T1 and T2 get inside at the same point of time, and it will let the other thread T2 to wait. So when T1 will do his job, will create the instance and come out of this lock method, then instance is already created, right? And then for the second thread T2, when it will go inside and it will check this null condition, it will fail because the instance is already created by T1, right? And it will return the same instance from here. So this is how now our this application is like thread safe. Our singleton pattern is like thread safe. So basically the one word answer is we have to use the lock to make our singleton pattern as thread safe. Okay. What is factory pattern? Why to use factory pattern? The first point you should know about factory pattern is the factory pattern is a creational design pattern and manages object creation. Okay, now I will show you the example first without factory pattern and what is the problem there, and then I will show you how to implement factory design pattern and resolve that problem. Okay, see this code. Here we have the concrete classes Java and .NET with concrete methods. Java get framework written Spring Boot, and .NET get framework method written .NET Core. Now we will use these method in a very normal way like this. See, this is the client code, and inside the main method we are creating the object of Java class and then calling the method and printing the value, and output will be Java Spring Boot. Same way we are creating the object of .NET class and final output will be .NET Core. Very traditional approach, nothing important here. Now here we have two problems with this approach. First is a lot of new keywords are here. See, new Java, then new .NET, right? And the second in a big application, if we have 50 technologies like Node, PHP, etc., etc., then you will be having 50 new keywords here, which will not look good. Okay. Second problem is inside the client code, client will know all the concrete classes names. Concrete means these are the actual classes like Java and .NET, right? So for some project, this is a security issue because they do not want to expose the actual classes name in their client code. Okay, so these are the two problems, and now we will solve them with the help of factory design pattern. And for that we have three types of factory design patterns. First is simple factory, then we have factory method, and the last we have abstract factory design pattern. In this question we will use the simple factory pattern, and if you will know then only you can understand the abstract factory and factory method. Okay, so in upcoming question we will explain factory method and abstract factory. Now here in simple factory we have an interface iTech with a method get framework. Okay, then two concrete classes Java and .NET which implement the iTech interface and provide their implementation of the get framework like this. Then we have a simple factory class tech factory with a method create tech that takes a string parameter tech type, and this method returns an instance of the corresponding Java or .NET object that implements the iTech interface, right? So if Java class is inherited from iTech, then it can return iTech interface. At last in the client code we created an instance of this tech factory. So this is the factory class, okay, this tech factory. So why we are calling it factory? Because it will now create all the objects. It will this main method or the client code will not create the class objects. So that's why this is factory, because it is a factory for creating the objects. So see, inside the client code we created an instance of the tech factory first and use it to create instance of Java and .NET by calling this create tech method with this appropriate tech type, whatever it is. Finally, in the output, the respective framework information get framework method, your output will be there. So your problem is solved. There are no new keywords in this client code right now, And second, we are not using even the concrete classes name here. See, no Java and I mean yes, we are using this Java and .NET strings here, but you can change this strings parameters strings, right, and make them something like J string or which are not related to Java name. Okay, so one caution here in factory design pattern, and that is it is not good for small projects. Okay, you can see how many lines of codes are here, and it needs lots of planning, right? So it's good for big projects which are really big, then it will be good, but not for small projects. Finally, now we will conclude the definition. Factory pattern provides an interface or abstract class for creating the objects, but lets the subclasses decide which class to instantiate. Okay, so interface, you know, one tech factory we have to create, and here instead of iTech interface, you can also see we have this iTech interface. You can also use here some abstract class, okay, with abstract method. Now this definition is slightly complex, so even you can make it more simpler, and you can say in simple factory pattern, one factory class, here tech factory stat class, is responsible for creating all the objects for its derived or subclasses. Okay, great. I think now you know some basics of factory design pattern, and also you know what is simple factory design pattern, right? How to implement factory method pattern? All right, as I said, we have three types of factory design patterns. Simple factory, I already explained, and here is the way we did simple factory, implemented simple factory in previous question. But the truth is, a simple factory is not considered as a good factory design pattern. The reason is because simple factory provides a single factory class. Here it is tech factory, okay, that created all the objects, while the factory method pattern uses inheritance and polymorphism. So it provides more flexibility and extensibility as comparison to simple factory. So factory method is the ideal design pattern, not the simple factory. Now I will show you how the factory method design pattern using inheritance and polymorphism. Okay, all right, here first, these product interface and these two concrete product classes are same as that of simple factory pattern. This code is same. Okay, now instead of stack factory, we will create one abstract class creator with abstract method create tech. Okay, then two more concrete creator classes will be there, Java creator and .NET creator, which are inherited from the this above creator class. Okay, the good thing is, as comparison to simple factory, we are not matching the strings. You remember, we are comparing the strings there in the simple factory, and that is not a very good way, right? Then at last, and also we are using inheritance first thing, like we are using this creator which is inherited in Java creator, and also we are using polymorphism like this override, right? This is a polymorphism way only. And at last, in the main method, we create instance of the Java creator and .NET creator classes, something like this, and use them to create the Java and .NET objects through the create tech method of the creator class. We then call this a get framework method on this object to show the output. So all is set here. Here you can see how inside the creator class this created tech is the factory method. That's why, and how we implement this factory method create tech inside the concrete creator classes here. That's why this design pattern because is called factory method design pattern. Okay, because we implemented factory methods here. And here is the same design if I will show you the same design implementation in like flow. So here it is, and which you have seen in most articles and books, I think. Now the point is, from interview point of view, I understand this whole thing is not easy to remember. Okay, it is not even possible. Yes, you when you want to implement it, you can refer something and then you can implement it. So but you cannot explain it very easily, yes. So but you can remember some points from the list I am going to share about simple factory and factory method design patterns, which you can share with anyone, and I think they are enough. So here is the first point. The factory pattern is a creational design pattern which manages object creation. You know it, right? Second point is factory pattern provides an interface or abstract class for creating object, but lets the subclasses decide which class to instantiate. So one class is there for creating objects, some kind factory class, but the subclasses will decide that which object they want to create, that decided by them. Then the third point is, in simple factory pattern, one factory class is responsible for creating all the objects for its derived or subclass. Very easy point, you can remember, right? And the next point is, simple factory pattern provides a single factory class that created the objects, while the factory method pattern uses inheritance and polymorphism to provide more flexible way of it. Okay, so these are 4 points which I think enough to know and which you can explain. Great, I think you did a great job in understanding this factory pattern now. What is abstract factory pattern? This is the third type of the factory design pattern. Here I will not show you the code here because it's too much of code and it's too complex, okay? But rather I will show you the basic idea of abstract factory, which you will easily understand, okay? You will understand when to use it and what it is for, this abstract factory pattern. Now suppose here we have one big IT company which is hiring directly the Java and .NET candidates, okay? What it is doing, it is doing it by itself. They themselves hiring it, this company. No factory pattern will be followed. They are directly creating the objects, you can say. But now next time this company will hire one agency which will act as the interface. Okay, now this agency will do the job of hiring Java and .NET candidates. So what happened? The creating of the object is the responsibility of this agency now. And this is quite similar to the factory method pattern, or a bit similar to this simple factory also. So because the object creation process is delegated to this interface, this some other class in between, okay, right? So now there can be more complex scenarios. For example, the same IT company is hiring tech candidates through a tech agency because they are expert in that, and non-technical candidates through a non-technical agency because they are expert in that non-technical domain, okay? So this is like now the abstract factory method pattern. So you can see we have increased the complexity from the normal factory method, right? The definition of the abstract factory pattern is: the abstract factory pattern is a creational design pattern that provides an interfaces for creating related families of objects without specifying their concrete classes. Now here we know every factory design pattern will not in the client code they will never disclose the concrete classes names, okay? So that also same thing abstract factory also do. Now what is this related families of objects? Here you can see finance and accounts are related families. Why? Because they are non-technical, okay? And similarly this Java and .NET are also related families. So like this, so this will be the structure of your classes in your single application, okay? But here is one more short definition of it is abstract factory, which is my favorite, and that is: abstract factory pattern can be thought of as a factory of factories, okay? So there are factories and you have one more factory over it. So this is the basic idea about the abstract factory design pattern.